All right, guys, here we go. 2.2 homework. Getting into some more fraction work. So let's see here. This first section, color the grid to show the fractions below. Each grid represents one whole. So just as a reminder here, these grids are 10 by 10. So there are 100 little squares inside there. So in other words, there's 100 little squares in this whole grid. Kind of like a dollar, right? So we got 100 cents, 100. So if we're looking for half, well, basically we're just going to we got a nice half right there, right? So if I kind of color in this half here, right? Something kind of like that. All we got to do is color in half. So that's what we're looking for on there. And then again, one half would be also 50 out of 100, right? So half of those. And again, 10 times 10. So we got 100 altogether on these. 1/4. Again, we're going to cut this into 4 equal pieces. It kind of already is, right? So it's kind of, something like that, right? So again, something like that. 3/10. Well, actually, hey, let's go back to that. 1/4. Again, what we can think about is on that 1/4, we can also multiply both these by 25, right? So we could think about 25 out of 100, right? So just keep in mind that's going to be 25 right there. 3/10. So 3 out of 10. So another way to think about it is we've got 10 maybe columns, or you could do rows. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's 10 altogether, and we just need 3 of those, right? So we just kind of need 3 of those right there. But again, we could also think about 3/10. This time we can multiply both by 10, because we can see this can be 30 out of 100. So again, we're just kind of remembering we can think of it a couple different ways, right? Again, ultimately what we'd want is just 3 of these. So 1, 2, 3, kind of about here, and then okay. Now 16/10. Well, that's going to be more than one whole, right? This is an improper fraction. In class, we talked about improper fractions where our numerator is larger than our denominator. So that 16/10 is really, we can think about that as 10/10 plus 6/10, right? So if we shade in this whole one, that'd be 10/10, and then we need to do 6/10 over here. Or in other words, 6 of these rows. Okay? Go back here. So we can shade in 10/10 on here, and then think about what 6/10 would be. Kind of like 6 dimes, right? If each one of these columns is worth a dime. And same with 6/4. Really, that's kind of like 4/4 plus 2/4. So that one whole, we're going to shade in that whole, and then 2/4, aka 1/2, right? So think about what that would look like. Now we need to, and actually we'll leave this here. It does say we can use these pictures possibly. Less than, greater than, or equal to. So 1/2 and 3/10. Well, 1/2 would be the same as 5/10, right? So without doing much math, we know 5/10 would be more than 3/10, right? How about this one? 6/4 versus 1 1/2. Well, that 6/4, really, we can think about 4/4, and yeah. I was almost going to go to a little lighter of a stroke on this pen, but that's 1 2/4, right? In fact, I think I might do that for the rest of these. because we're getting some notes down here. We'll zoom in a little more. That 6/4 we can really think about as 4/4 plus 2/4, right? That 6/4, we see there's a hole right there. So that's 1 2/4. So improper fraction versus mixed number. So now think about if I have 1 2/4, compare that to 1 1/2, which is bigger. 6/10 versus 3/4. One thing we could do is, again, if we're using these grids, that 6/10. You can think about this however you want. If we kind of think about money in class we've been talking about, if I have 6 dimes, we could multiply both these by 10. So we could think about this as 60 over 100. And then if I have 3/4, we could multiply both these by 25. So we get 75 over 100. So 60 cents versus 75 cents. Kind of go from there, right? 16/10. Well, look at D. When you're done with that, see what you get up here for letter D. Is that going to be more, less, or the same as 1 1/2? Kind of go from there. 6/10 versus 6/4. Again, 6/4 is going to be right here, which we can see was going to be 1 whole and then 2/4 more. Kind of go from that. I don't think, yeah. So as far as 6/10. So that D is going to go with the E. See what that picture looks like. We could also get common denominators. Instead of doing money, we could also just think about getting a common multiple, right? We know we could write these both as something over 20. Well, 10 times what is 20? Well, 10 times 2. Do the same to my top. So 6 times 2, that's going to be 12. And then how about 4? 4 times what is 20? 4 times 5, I got to do the same up top. 6 times 5. 6 times 5 is 30. So I think we can see clearly which one is going to be more. And then I'll let you think about this last one here, 3/10 versus 1/4. We did a couple ways. Here in B, we brought them over 100. D, we brought them over 20. Whatever strategy works for you, figure out which one's less than or greater than, okay? And then, again, we are going to be adding some fractions here. And it says you can think about money if you want. I guess we'll leave these lines here. I'm going to actually, let's do a little more work over here. So letter A, let's just kind of set up some work here. So we got 1/2 plus 1/4. And in class we say if we can keep the larger denominator, that keeps some of the work done for us. So can we keep the 4? Well, 2 times what is 4? 2 times 2 and 1 times 2. So 2 times 2 is 4. And we can leave this 1/4 alone. So if we can leave one fraction the same, we don't have to do any work to that. This one, 2 times 2 is 4, and 1 times 2 is 2. So 2/4 plus 1/4. Well, if we have common denominators, we're good. So that's going to stay as 4, and 2 plus 1 is 3. So altogether, that's going to be 3/4. Okay, and just get in the habit of showing your work like this. Every step. Just show every step. And how about B? We've got 1 1/2 plus 3/4. Okay. Well, again, we can get common denominators, so we can get that 4 again. So 2 times 2 and 1 times 2. So again, we're going to get 4 for a common denominator. So 1/2 we can think of as 2/4. We just cut our slices a little smaller, our pieces a little smaller. So 1 2/4 plus 3 more fourths. Think about what happens on that. And then we just want to see some work, how you're getting your answer on that. Yeah, I'll go ahead and give you that, guys. We'll put the answers on these so you can check your work. So our final answer is going to be 2 1/4. I just need to see a little more work on that one. And then C, I think we can kind of work from there. The book says a couple ways we could either think about this as 60 over 100. Well, I'm going to put 6/10 because we can keep our 10 for a denominator. And for this one, I would get 20 as a common denominator for letter D here, right? Because I know 10 times 2 is 20, and 4 times 5 is 20. Whatever we do to the bottom, do to the top. So think about what we need to do to get what's going to happen to our numerators. 2 and times 5. Now our final answer is going to be 11/20. So go ahead and show me how we got that, okay? Sweet. Okay, Francisco and his mother bought some fruit yesterday. They bought 2.5 pounds of peaches, 7/10 pounds of raspberries, and 1 1/4 pounds of apricots. How many pounds of fruit did they buy in all? So let's just start by writing out our problem. So we got 2.5 plus 7/10 plus 1 1/4. So the question is, how can we get a common denominator for all three? You know, one thing we can do is start with our largest denominator. Does that work? Well, 2 times 5 is 10, but 4 times something is not 10. So let's just kind of start adding 10. How about 10 plus 10 is 20? Will 20 work? Yeah, 2 times something is 20. 4 times something is 20. So let's rewrite all of our fractions as something over 20. And I'm going to add my whole numbers real quick as well. So we got a couple things going on. So I got this 2 and the 1. So 2 plus 1 equals 3. So we have 3 for a whole number right now. All right, let's go back to our fractions. So 1/2, 2 times what gets me to 20? 2 times 10. So I got to do the same with my numerator. What's 1 times 10? 10. So 1/2 and 10/20 are equivalent. They're worth the same amount. Okay, how about over here? 10 times what is 20? Well, 10 times 2. So I have to do the same to my numerator. What's 7 times 2? 14. So 7/10 and 14/20 are equivalent. And then finally, 4 times what is 20? 4 times 5. Do the same to my numerator. 1 times 5 is 5. So 1/4 and 5/20 are equivalent. We're just cutting our pieces so they're the same. So now we just have to add 10 plus 14 plus 5. Let's see, 14 plus 5 is 19. Plus 10 more is 29. So we're going to get 29/20. So we might think about this as 3 and 29/20. Right, we had our 3 from up here, our fractions end here. But in class we talked about you can't have an improper fraction inside a mixed number. That's a no-no. So, well, how can we break that 29/20 apart? So we got our 3. Well, that 29/20 is kind of like 20/20 plus 9 more 20ths, right? 29, that if we take that 20 plus 9, but that's a whole right here, right? So why don't you guys go ahead and finish it from here. I got 3, we found another hole, and then we got 9/20 left over. Okay, and yeah, we're this far. So 3 plus, really this is like 3 plus 1 plus our 9/20. So 3 plus 1 is 4, and we had our 9/20. Okay, so that's how I would set it up. Maybe you went a different route. But again, if we can get a common denominator, that's what it's all about. Now, 5 does say challenge. It's not that challenging. We can handle this. It says, write 3 fractions addition problems in which the fractions have different denominators, but their sum is 1. So we got to come up with 3 different problems where our final answer is 1. We want it to be 1 on all of these. Well, 1/2 plus 2/4. Look at all they did is they wrote 1/2 a different way. So 1/2 plus another version of 1/2, right? Because 2/4 equals 1/2. So let's do that. Let's do another one. We can do 1/2. What's another way we can write 1/2? How about 3/6? Is that the same as 1/2? Yeah. So if you want, just write a few different ways to write 1/2 plus 1/2 a different way. Or maybe you could do 3/4 plus 1/4 a different way. So you would kind of have fun with this. You can maybe, or how about tenths? Let's set one more up for you. What if we have 9/10 plus how many more tenths equal 1 whole? In other words, 9/10 plus blank tenths equals 10/10, right? Because 10/10 is the same as 1 whole. So have fun with that. Think of different ways you can get 1 for an answer. All right. This next part, we're shading in. Now I'm going to use a couple different colors for these. I'll do it like the book. So 1/2. Now in class we also talked about these are all 8, right? I could take this big bar and cut it in half, and then we're shading in just half of this bar, right? Or we could also think about this as 1/2 is the same as what over 8? Well, 2 times 4, so 1 times 4, so 4/8, right? Move this over just a hair. So something over 8, 2 times 4, so 1 times 4, so 4/8. That's how we got 4 technically, right? And then we're going to start by filling in 3, 1, 2, 3. There's that first part. The next one says 3/8. Oh, okay, so that's just 3 out of the 8. That's already an 8. Nice. A little bigger on this one. And then we'll do 3. 1, 2, 3. Actually, you know what? It kind of covers it up too much, so we'll go back to this one. So what ended up happening on this, 3 plus 3 is 6/8. Now, no, I'm sorry. Getting ahead of myself here. We need to shade in 4 of these. Sorry about that. 1, 2, 3, 4, right? It was half. You're like, what are you doing? Then we got 3 blue. 1, 2, 3. Okay, there we go. 1, 2, 3. I was kind of looking at the wrong one there. So all together, how many do we shade in? It's a little different with this pen, by the way. So we shaded in 7 out of 8, didn't we? So that's what we're looking for on that one. And again, that 3/4, we could also think about as how much over 8? Well, 4 times 2, so 3 times 2 is going to be 6. So 6 out of 8. So 1, 2, I'll do the squares individually. 1, 2, 3, 4, 5, 6. All right, then I'll shade in 6 here. 1, 2, 3, 4, 5, 6. Okay, and the next one says, see, my son's still got about 20 more minutes in practice, just making sure. 3/8 again, so 1, 2, 3. So we're going to shade in 3. 1, 2, 3. So we're just adding those pieces together. Now we can see we shaded in 1 whole bar, so that's 1. And then just 1/8 left over. So 1 out of the 8, we're good there. So keep that in mind. I'll give you guys the final answer on these. But I need to see how it worked out. So this is also going to be 1 1/8. And this is going to be 1 5/8. So make sure we understand how we got there. But those are the final answers if you want to check it. Then we get to these clocks. Now remember, the clock is out of, it's got 12 pieces, right? There's 12 hours. So again, for 1/4, I can cut it into fourths and shade that in. And if I go over here, we're going to shade that in. There's that 1/4. And then 2/3. All right, in class, we talked about thirds. Go straight down. And 5, 10, 15, 20. The 20 minutes, and then also 40 over here. 25, 30, 35, 40. All right, and then we want 2 out of these. Well, we can see each third is kind of 4 slices here. So 1, 2, 3, 4. And then 1, 2, 3, 4. So you can see we almost shaded in that whole clock. There is only 1 slice left, right? Just that 1 slice left right there. So we had 11 out of 12 slices. The next answer is going to be 1 5/12. So we're going to check your work on that. Then 1 7/12. Again, this one we had fourths and thirds again. Real quick, sixths. We talked about if I do thirds and I cut my thirds in half, now I have sixths. And also notice your sixths are kind of like a double slice. There's 2 pieces on each one. Fourths we're good with, half, then again sixth. And we'll talk more in class, but this last one, we're going to get 1 2/6. But we could also simplify that to 1 1/3. Or you could also think about it as 1 4/12. So we're going to have 4 out of that 12. So we'll talk more in class, but keep that in mind as you're working through it. All right, up next, Abby and Lauren are preparing for dance performance. On Monday, they practice for 2/3 of an hour. On Tuesday, they practice for 5/6 of an hour. How long do they practice on Monday and Tuesday together? All we're doing is adding 2/3 plus 5/6. Now, can we keep the larger denominator? Sure can. Let's keep that 6. So we're going to leave 5/6 alone. He didn't do anything. Leave him alone. Leave your brother alone, right? Because 3 times 2 is also 6. Whatever, do the top, do the bottom, do the top. So 2 times 2 is 4. So 4/6 plus 5/6. Looks like we're going to get something more than 1, right? Our final answer, if you do want to check your work on this, it's going to be 1 1/2. So show me how you got that 1 1/2. We're not quite there yet. So show me that work just to finish that up. And then on Wednesday, they couldn't practice together, so they practiced separately. Abby practiced for 11/12. Lauren practiced for 2/3. How long did they practice on Wednesday? So again, we're just adding these parts. 11/12 plus 2/3. Hey, we can keep the 12ths, right? So we got 11/12 here. And then 3 times what is 12? 3 times 4. Do the same to the top. So you can think about, we got 12ths, and 2 times 4 is 8. Okay. So the final answer is going to be 1 7/12. And we're going to talk about how we know we can get to that, okay? Now, 4 and 5 are challenges, but they're not really too bad. I think they're a good concept, so I left them in. So number 4, we're adding 2 fractions that are both greater than 1/2. What must be true about them? Well, if each fraction is a little bit more than 1/2, if it's a little more than 1/2 plus a little more than 1/2, it's got to be a little over a whole, right? And that's really what the answer is looking for, is it's just going to be greater than 1. Let's go, for example, twelfths. Well, 6 twelfths will be 1/2. So what if I have 7 twelfths? Just a little bit more plus a little bit more. And my example, that'd be 14 twelfths. So the sum must be greater than 1. The key is it's got to be more than 1 whole. Because it's a little bit more than 1/2. How about 51 cents plus 51 cents? That's $1.02. It's a little more than 1 whole. And then the opposite would also be true. What if we're adding 2 fractions that are both a little less than 1/2? If 2 fractions are both just a little bit less than 1/2, right? Let's say we're adding 49 cents plus another 49 cents. Well, that's going to be 98 cents. It's going to be 98 cents. So the sum must be less than 1. It can't quite be 1 because they're both less than 1. It can be really close, but we know it's going to be less than 1. All right. Here we go, guys. Now we're going to look at some charts. All right, so these are kind of fun. Just really look carefully at our charts here. We got 4th grade favorites and 5th grade favorites. So we got cheese pizza, turkey burgers, chicken nuggets, and our salad. So 4th graders, we see half of them really like that cheese pizza, a quarter like turkey burgers, and then the last parts are split 1/8 each for nuggets and salad. Where the 5th grade, it's a little more evenly split out, right? 1/3 like the pizza, 1/3 like the burgers, and then this is 1/3 left here, right? But we're going to split those into 1/6 each for the salad and the nuggets. And then we're just going to have to answer a few questions based on this. So what fraction of 4th graders did not vote for super salad? Well, first of all, what did vote for super salad? So 4th grade super salad is right here. So if 1/8 did vote for it, really we're just doing what is 1 whole minus 1/8, right? So it's just not 1/8. All the rest of them voted for it. So it's going to be 7/8, right? And then how about B? What fraction of 5th graders voted for turkey burgers or chicken nuggets? And this one we're going to add those two pieces together. So 5th grade, turkey burgers, right here. Okay, 1/3. You can't look at the chart. And the nuggets are in white. So down here, you might notice the chart kind of does something similar, or something interesting. So turkey burgers are the light gray, so 1/3. And the nuggets are white, 1/6. So we're going to have to add 1/3 plus 1/6. Get your final answer there. Now I will tell you, so that's the final answer here. The final answer for this one is going to be 1/2. But show me how you got 1/2 here. Don't end it here, okay? So 192 4th graders voted altogether. 192 4th graders voted. How many of them voted for turkey burgers? So turkey burgers are this light, so 1/4. So what we need to do is find 1/4 of 192. In other words, and I'll set this up over here on the side, what is 192 divided by 4? So 1/4 voted for that. What is 192 divided by 4? Okay, so 1/4 of it just means we got to find 1/4 of that. Now, if 774 5th graders voted, how many of them voted for chicken nuggets? Well, chicken nuggets was 1/6. So out of the whole 174, we're going to find 1/6 of that. So again, very similar. We're going to do 174 divided by 6. Okay? So figure that out, see what you get there. And then our last page is going to continue this idea of finding a percent of a number. So we're looking for a half of 60. Really, these are just going to be division problems. If it's 60, 1/2 of 60, that just means 60 divided by 2. What's half of 60? 30. Okay? For B, and we'll say A right here. For B, 1/3 of 60 is just 60 divided by 3. So what's 60 divided by 3? You know, for C, 1/2 of 100. What's 100 divided by 2? And finally for D, 1/5 of 100. Well, what's 100 divided by 5? That's all we got to do on those. All right, last few problems. Here we go. While waiting for his grandma to arrive, Patrick spent a half hour on the phone with a friend and a quarter of an hour listening to the radio. How long did he spend waiting for his grandma? Write it as both minutes and fractions of an hour. Well, what do we got to do? We got to do 1/2 plus 1/4. Okay? And we'll talk about that in class. Not only a fraction. Now, for minutes of an hour, just think about how that would work out as well. So if you just have the fraction, that's fine. We can go from there. But think about how that would be minutes. Beth walked 1/3 of a mile from her house to her friend's house, 1/4 of a mile to the post office, then another half a mile back home. How far does she walk in all? Well, again, we're going to have 1/3 plus 1/4 plus 1/2. Okay, all we got to do is find one common denominator for all three of these. Again, 4, well, 2 times 2 is 4, but 3 times something is not 4. Okay, what if 4 plus 4 is 8? Well, 2 times something is 8, but 8 doesn't work with 3. Add another 4, how about we get to 12? So we can rewrite these as something over 12. Don't worry, hon, I won't forget. My son actually rode his bike to practice tonight because we were at volleyball with our daughter. So my wife's like, don't forget his bike. So we're just going to rewrite this as something over 12, right? Here we go. 3 times what is 12? 3 times 4. So we got to do 1 times 4. Okay, 4 times what is 12? 4 times 3. We got to do 1 times 3. 2 times what is 12? 2 times 6. And 1 times 6. So think about your new numerators, what they're going to be. Add them up. And I'll tell you it is over 1. Well, heck, I'll give you the answer. Why not? Because you still got to work it out. Our final answer is going to be 1 and 1/12 miles. And last but not least, challenge. Again, we say these are just slightly harder. This one's probably not even too bad, really. It's just a little more wordy. Just organize your work and figure it out. Rodney and Josiah each bought a package of the same kind of cookies at the store. Rodney ate half a package of his cookies on Monday, a third of the same package on Tuesday. Josiah ate 3/5 of his package on Monday, and then the half of that package on Tuesday. Who ate more, and how much more? All right, so we got Rodney. Now, he ate half of it right away. Whoops, not 1/12, half. He ate half of it right away on Monday, and then the next day he had a third. Okay? And then we got, was it Josiah? Josiah ate 5/12 of his package, and then he had half of the package. All right, so cool. Let's see the common denominators for everything. The largest denominator I see is 12. Can we keep 12 for all these? 2 times 6, 3 times 4. Yeah, we're good. So let's write all these over 12. So 5/12 we can leave alone. We don't need to change that. All right. So 2 times what is 12? 2 times 6. Whatever you do at the bottom, do at the top. Okay, 3 times what is 12? 3 times 4. And 1 times 4. Okay, so we got 1 times 6. That's going to go there. 1 times 4. That's going to go there. 5/12 we leave alone. And then 2 times what gets me to 12? 2 times 6. So we got to do 1 times 6. 1 times 6, that's going to go right there. Once we have our new sets of fractions, we can add them up. And there's 2 things we got to answer. Who had more? So either Rodney or Josiah. And then figure out how much more. I will tell you, it's going to be really close. So, awesome job on this. If you needed this help, hopefully it was helpful. As always, just reach out with any questions, guys. Keep up the great work. See you in class.